Welcome, cadets. You've been training for this moment. And believe me, this USEC assignment, it isn't just another lab. This is your transition point, that leap from being a student who just writes code to becoming a developer who designs entire systems. Your assignment isn't just a test, it's a rescue mission. So listen up. Here's the briefing.
It's been exactly 1 year since the incident of October 31st, 2024. On that night, right here in the Android lab, 38 of your fellow students were pulling a midnight coding session when they were caught in a freak electrical storm.
Now, this wasn't just any storm. Lightning hit the building's solar array, overloaded the entire grid, and created a spontaneous plasma conduit right through the computer network. Security footage caught the exact moment, 11:59 p.m., the witching hour, when every single terminal in that room just flared with this eerie golden blue light.
And just like that, they were gone. For 12 long months, all we've had are fragments, echoes of their digital presence, corrupted files that almost seem to whisper, glowing network packets pulsing away like little heartbeats. We haven't been able to reassemble them. They're lost in the system.
But tonight, that's going to change. The energy surge is predicted to happen again, creating the perfect conditions. And that's where you come in. You are tasked to deploy the Rescue Protocol system. Your code will build a network of objects that can grab those lost data patterns, reassemble them, and bring our students back.
So how are you going to pull this off? You're going to use a powerful architectural principle known as the ghost in the machine design pattern. And let me be clear, this isn't some academic theory. This is how professional enterprise systems get built every single day.
The whole idea is actually incredibly elegant and it's powerful. It's all about separating the data, the ghost, you could call it the soul, the identity of what you're modeling, from the machine, which is the system that contains and controls it. Starting right now, this is how you're going to think. And you have to remember this critical separation. The ghost is your data object. It represents a lost student's identity, their attributes, their current state. The machine? That's the control system you're going to build. It's the class that holds onto these ghosts, manages their entire life cycle, and, well, gives them purpose.
Okay, so let's break down how you're actually going to construct this rescue protocol. Here's your plan of action, step by step. Your construction is going to follow 4 key phases. And the beauty of this is that each one maps directly to a core object-oriented concept. You're going to build a more sophisticated, more robust system as you move from one step to the next.
So first up, encapsulation. This is the principle of bundling your data and the logic that works on that data together in one safe little package. You'll model the lost students as data objects. These are your ghosts. Then you'll build a containment controller, that's the machine, which is a class that safely holds and manages a list of these ghosts, protecting them from all the chaos on the network. Next, you have to establish a communication protocol, and you'll do that using interfaces. See, an interface is like a universal contract. It defines what a class can do without getting bogged down in how it does it. The ghost signals are fragmented. Some are vocal, some are visual. So you'll use an interface to create one standard, one consistent protocol, so your controller can handle any type of signal that comes its way.
Then, to manage all this complexity, you're going to use inheritance. This lets you create a new class that automatically shares the properties and behaviors of an existing one. You're going to find that the entities you rescue are fragmenting into different echo forms. An abstract-based class will define the core essence of all entities, while more specialized classes can handle their unique forms. It's all about reducing duplication and bringing order to chaos. And finally, to prioritize who gets rescued first, you need to classify each entity's state. You'll use enums for this, a special type that represents a fixed set of constants. This will let you categorize their energy levels, things like stable, flickering, or unstable. It's going to make your system's logic clean, easy to read, and a whole lot safer.
And here it is, the complete system specification. Just take a look. Every single requirement of this mission, from the student data class to their energy signature, maps perfectly to a core programming concept you've learned. This, cadets, is exactly how elegant architecture is born from chaos.
Look, completing this mission does a lot more than just rescue some digital ghosts. It's going to fundamentally transform you. You're not just learning to code anymore. You are training to command digital systems.
But the real transformation, that happens in your mindset. When you build systems with this kind of planning, with this kind of precision, you gain a deep, powerful competence,
It's that quiet confidence that lets you walk into any complex project, look at the code, and just get it. You'll know what's going on.
This right here, this is the leap you're taking. You're moving beyond just worrying about syntax to actually seeing the architecture, the living, breathing mechanism beneath the code. You're becoming an engineer, a conductor, a rescuer.
You will have learned to build with structure, with planning, with precision. You will have created a machine that commands its ghosts. You will have earned your place here. Welcome to the big leagues.
The protocol is in your hands now. The ghosts are waiting. Go build.